Bismillah ar-Rahman ar-Rahim. My dear students at Retail International Academy, here we will talk about the application of common law, of Ohm law, of Ohm law. Here, what do we mean by voltage? Volt, its battery took this shape, and here each one of them we call it as a resistance. Here we have the current, how we measure a current at a circuit by the ampere. Ampere as a unit. We call the instrument we use it to measure the ampere. We call it as a meter. So this is we call it a meter. Here we use this to measure the voltage. We call it voltmeter. So here resistance. When we have resistance in this shape, they come after each other. We call this resistance. They come at series. And series we could replace them as a one resistance only. So let us try to solve the question, and we will talk later on about this application. I have this example. I have a voltage source with 5 volt. I have a resistor here, first resistance with value equal 2 ohms. I have the second one, I don't know it. And I measure the current on a circuit, and it gives me it's equal 1 amp. So how we could find the value of resistance? We know this value, or this equation, V equal IR. How we could use it here? I told you that each resistance here, they come after each other. We call them a series, and we just add them and replace on a circuit as a one resistance. So I could use this law. I have V equal 5 volt. It's gave it to me. I have current. I measure it is equal 1. So instead of I write it 1. Then open a bracket. I have a 1 resistance equal 2. So it's 2 plus R2, which I don't know it. So 5 volt equal 1 amp times 2 plus 2 ohm plus R2. So now divide each side by 1, or we don't have to divide it because 1 does not change anything. 5 volt equal 5 over 1 remain 5. 5 equal 2 plus R2. So now subtract 2 from each side. Minus 2 and minus 2. 5 minus 2. So R2 equal 3 ohms. So I could add them together at the same circuit and make the circuit as a one single resistance with value of 5 ohm. Look at here the example we use it. We have a voltage which equal 5 volt. I have a resistance equal 3 ohm, and the second one equal 2 ohms. So I measure a current. Look, it is 1 amp. So I told you when they are in series, I could replace them only with one resistance. So I'm going to cancel this one here. I connect them here. I could make this as, look, 5 volt, 5 ohm, give me 1 amp. So if you see that, 2 and 3 series is equal 5 ohm. So I replace them with only one resistance. So it's give me the same value. Now in the exam, if you have questions asking you about electrical power, so we have power equal IV. I have 3 equations for them. One of them is I, current, times voltage. The second one is voltage squared over resistance. The third one is I squared times R. Okay, if it's regarding all circuit, I have to replace all resistance or current. Depends. So for previous questions, if they're asking us about for the previous question when we finding the R2, Here, let us try which one are we going to use. I prefer to use V squared over R. So 5 equal 5 volt. R equal 5 ohms. Be aware here it is the whole resistance. So 5 squared, V squared, 5 squares over 5 give me power equal 5 watt. If you use either this one or this one, you will end up with the same value. Here I was 1 squared 1 times R 5, 1 times 5 watt again. Here we have I 1 volt equal 5, 1 times 5 equal 5 watt. Depends which values you have in your circuit. So this is how we find electrical power. Either this one of these equations. Here is an important rule about electrical current. Current in equal current out. If I have this diagram, I always looking for a point where is all current, where are all current accumulate. Here I have 5 amp in, I have 2 amp in. So electrical current in equal current out. Current in equal current out. So what is the value of the current go out? So just add them. 2 plus 5 give me 7 amp. Here again, if you have 2N and 4N, what is the current go out? Again, you could see that 2 plus 4, because they are N, must equal the current go out. So 2 plus 4 equal, so the current go out is equal 6 amp. So this is the revision for your exam. I hope you find it very helpful. Thank you all and good day to you.